Hi everyone, and welcome back to part 2 of this video on solving equations. We covered the first 5 problems in the first half of the video, and this one I'm going to cover problems 6, 7, 8, and 9, which all deal with quadratic equations. Now, this word quadratic, this is something we've seen previously in the context of expressions. So a quadratic expression, just to remind everyone, any algebraic expression that looks like this: ax plus bx plus c, where a, b, and c could be any real numbers. Any real numbers with one exception: a could not be 0. So we'll say a, b, and c are real numbers. When I say real numbers, I'm talking about whole numbers, fractions, positives, negatives, could be 0, could be decimals, could be square roots, irrational, any numbers except a cannot be 0. So this is a quadratic expression. A quadratic equation looks identical to this, except it's in the form of an equation. So we'll just tag on an equals 0. So a quadratic equation, if I could fit it here, not too much space, but we don't need that. Let's put a little box around here. The equation of the form ax squared plus bx plus c is equal to 0. Now, an equation like this, and this is actually a rule of all polynomials, which we'll talk about later, but since the highest power is 2, this equation can have up to 2 solutions. There may be 2 answers, there may be 1 answer, there may be no answers. We'll talk about a little bit later how to determine the number of answers, the number of solutions we're looking for. But what I want to do is talk about a couple of different ways, a few different ways of solving a problem like this. Now, one topic that we spent quite a bit of time with earlier, previous video, is factoring quadratic expressions. That's definitely going to come into play in this video and in the context of solving quadratic equations in general. So I'm going to go through 3 problems to solve, and then a 4th problem, which focuses just on figuring out how many answers that we're expecting or that we're looking for. Okay, so a couple of properties that are going to be important here. 1, the square root property. The square root property. So for example, if I were to ask you what is the square root of 9, you might say 3. Square root of 9 equals 3. Okay, so another way of asking this question would be to say, solve x squared is equal to 9. So something squared is equal to 9. And if you take the square root of both sides, square root of the left, square root of the right, you might say, okay, well, the square root of x squared is x, and the square root of 9 is 3, so we get x equals 3. It's not exactly how it works. And actually, this is not actually correct. It's not technically completely true. It's partly true. The square root of 9 doesn't only equal 3. 3 is what's called the principal square root, the positive square root of 9, but there's also a negative one. So if we go back to solve the equation, x squared is equal to 9, what we're asking here is the same thing we were asking over here. What number times itself gives you 9? So if I put a question mark here, the square root of 9, the same thing. I'm asking, what number times itself is equal to 9? Well, you would say, okay, well, 3. 3 times 3 is 9, so x is equal to 3. That's one solution. But what about negative 3? Negative 3 is also a solution because negative 3 times negative 3 is also 9. So if we replace the x in this equation, x squared minus 9, if we replace that x with a 3, 3 squared equals 9. Is that true, yes or no? Well, yes, it's true. So 3 is an answer. But if we replace the x with the negative 3, then we get negative 3 squared is equal to 9. Is that true, yes or no? Negative 3 times negative 3 is 9, so check. That is also true. A solution or an answer is any number that makes the equation true. If you replace the x with that number, it makes the equation true. So there are actually two square roots of 9, 3 and negative 3. 3 is the one the calculator is going to give you. If you just type in square root of 9 on a calculator, you're going to get 3. That's one of the two answers. It's one of the two square roots of 9. That's called that's the principal square root. So simply put, we can say when you take the square root of both sides of an equation, when you take the square root of both sides, what you need is, well, you need a plus minus. You need a plus minus. So another way of saying x equals 3 and x equals negative 3, a more compact way of saying that is x is equal to plus or minus 3. So that's two answers right there. X equals plus 3 and x equals minus 3. Positive 3 and negative 3. Okay, so that's the square root property. So problem number, I think we're on number 6. Yeah, problem number 6. Now, I can't say all the time it's going to tell you in the directions which method to use. It's probably not. When you see quadratic equations in homeworks and quizzes and exams, you're most likely not going to be told, solve this equation by the square root property, or solve this equation by factoring, or solve this equation by the quadratic formula. But since this is an introductory video, I'm including the type of problem in the directions. Okay, the square root property is usually the best approach, almost always the best approach for when b is 0. When the b is 0, so ax squared plus bx plus c equals 0. The a is some number, the c is some number, but the b is 0, so this term isn't there. So you actually have ax squared plus c is equal to 0. Which is what we have here. If we subtract 27 from both sides, you would have a 0 on the right. So this equation is of that form. Okay, so how do we solve this? This is actually not bad. As far as the whole spectrum of quadratic equations go, this is on the easier end of the spectrum when you're using the square root property, when the b is 0. So the b is the number in front of the x. So we have in this equation an x squared and a number, but there's no x to the first power. Okay, so what we want to do is get this x squared on one side, number on the other side. And we want to solve for x, but to do that, first solve for x squared. So to use the square root property, isolate the x squared. We can subtract 9 from both sides. So let me write this a little bit bigger and more centered. 3x to the second power plus 9 is equal to 27. So we can minus 9 minus 9. Okay. So the 9's cancel. We're one step closer to x squared by itself, but we still have a 3 there. 3x squared equals, 27 minus 9 is 18. Okay, we want to get x squared by itself, so we can divide by 3. Right now, the x squared is being multiplied by 3, so we do the opposite. We divide both sides by 3, so those 3's cancel. We have x squared is equal to 6. And now we're going to use what we had on the previous slide. Take the square root of both sides of the equation, or thing. What's the square root of 6? So we're basically, let me rewrite this. Let me rewrite this. X squared equals 6. What we're doing is taking the square root of the left, and we're taking the square root of the right. So on the left-hand side, we get x, and on the right-hand side, we get plus or minus the square root of 6. So we have two answers, the square root of 6 and minus the square root of 6. And we could always check that our answer is indeed an actual answer by going back to the original problem, 3x squared plus 9 equals 27. Now, we have a 27 on the right, which means if this is an answer, once we plug it in for x, we better get a 27 on the left. This should give us 27 equals 27, which is a true statement. So 3, we'll replace the x squared with the square root of 6, and then there's a plus 9 equals 27. That's 3 times, well, the square root of 6 times itself is the square root of 36, or just 6, plus 9 equals 27. 3 times 6 is 18. And 18 plus 9 is 27. So that checks out. This is not part of what's required for this problem. This is more checking our answer to make sure it works. Or also, in this video, we're exploring what it means to be an answer, what it means to be a solution. X equals the square root of 6 is one of the answers, because if you replace the x with the square root of 6, you get a true statement. And if you take negative square root of 6, plug it in there as well, you also get 27. Okay, so that's the square root property. Ideally, we use it when the b is equal to 0, or there's no term, there's only an x squared, there's no x to the first power. Okay, so that's one approach. Now, next approach I want to talk about, solve by factoring. Solve by factoring. Now, this method, this is something you should always try. Not every quadratic equation can be factored with whole numbers. So if a quadratic expression cannot be factored with whole numbers, we call it a prime quadratic expression, like a prime number. And we have to use another method, a different method. But if you can factor, it's a great way to solve these problems. Now, before we factor, let's talk about property number 2. Right, let me go back a slide or two. The first property was the square root property. That's this guy right here, the square root property. We use that for the first problem. Now, in problems that we're going to factor, we use what is called the zero factor theorem. The zero factor theorem. Now, what the zero factor theorem is saying is that if you have the product of two things, a times b. Now, let me write this as an if-then statement. If a times b is equal to 0. Now, a and b could be numbers. They could be variables. They could be algebraic expressions. They could be anything. But if something times something is equal to 0, then it must be true that either the a is equal to 0 or the b is equal to 0, meaning you can't multiply two things and get 0 unless one of them is 0. You can't multiply two things together and get 0 unless one of them is 0. So let's see how that applies here. If we factor x squared minus 2x minus 63, we get x minus 9 times x plus 7 on the left, and we still have equals 0 on the right. Okay, so zero factor theorem is over here. The previous video, I think it was section 5. I think it was section 5 where we did factoring. I'm not going to re-explain factoring in this video, but if you're struggling with factoring, it's something you want to take care of sooner than later because it's a huge part of any algebra or pre-calculus course. So it's basically factoring is the reverse of multiplication. So assuming you could factor, and again, if not, please go back to the previous video. But assuming you could factor, we get x minus 9 times x plus 7, which is equal to the left-hand side. And so this is our A, and this is our B. And we have A times B equals 0. And what the zero factor theorem is saying is, if you have two things multiplied together to give you 0, then you could split it up into two equations. Equation number 1 is A equals 0. So x minus 9 is equal to 0. We could add 9 to both sides. So we'll throw a little plus 9. They cancel. And we get one of our solutions, which is x equals 9. So that's answer number 1. And then going back to the zero factor theorem. Where did we go? Here we are. Going back to the zero factor theorem, if a times b equals 0, then a is equal to b, or a equals 0, or the b is equal to 0. And in this case, the b is the x plus 7. So this is a great theorem because it allows us to, once we have an expression factored, it allows us to look at each factor separately. So smaller problems instead of two or more smaller problems instead of one big problem, if you think about it that way. Minus 7 from both sides. So we'll have x is equal to negative 7. All right, so solve by factoring means factor, first you need a 0 on one side. If that 0 was any other number, you would have to subtract it, bring it to the other side. You must have ax squared plus bx plus c is equal to 0. If you have an equation that looks like that, then you can solve by factoring. Okay, but like I said, not every problem, not every quadratic expression can be factored. So I should have probably made this number 9. I'm going to skip number 8. I'm going to go to number 9, and then I'm going to come back to number 8, and I'll tell you why. Number 8 uses part of the quadratic formula, part of it. So I want to talk about the quadratic formula first. We could solve this problem and then go back to the previous problem. So the quadratic formula, it's another if-then statement. If, and this is the same as the zero factor theorem, if ax squared plus bx plus c is equal to 0. You have to have a 0 on one side. If you have a quadratic expression, equal 0. Then the answers. You have two answers, potentially two. Could be 0, could be 1, could be 2 answers, but up to 2 answers. So if, let me write this a little bit further to the left so I have some more room. Then your answer or answers are x is equal to negative b plus or minus the square root I'm going to use a slightly different color here. B squared minus 4ac under the square root, all divided by 2 times a. So the a, b, and c in this formula are the a, the b, and the c in the original problem. So for the problem on the left, well, it's not equal 0. So the very first thing we got to do is get rid of that 10. Minus 10 from both sides. So now we've got x squared plus 4x minus 10 is equal to 0. The a is the number in front of the x squared, the b is the number in front of the x, and the c is the constant on the end. So for this problem, we've got a is equal to 1, because it's 1x squared. B is equal to 4, 4x, and c is equal to negative 10. So those three numbers, the 1, the 4, and the negative 10, these three numbers here, you plug them into that formula. You replace the A's with 1s, you replace the B's with 4s, and you replace the C's with negative 10s. You'll notice I wrote the if and the then somewhat far apart. The reason I did that is because to get from the if statement to the then statement, where does the quadratic formula come from, for example? It is a result of a process called completing the square. Completing the square. So this is another method for solving quadratic equations. Completing the square is similar to the quadratic formula in that they both always work. 100% of the time, they're going to give you your answers. Solving by factoring, like we did in the last problem, doesn't always work because you can't always factor every quadratic expression. So factoring only works when you can factor. So completing the square, it's a little bit algebraically cumbersome. And the process of deriving this formula, I might put it in a separate video, but it's about 12 steps, 14 steps of algebra. It's pretty, it's pretty dense. So it's not necessarily going to help us in terms of solving quadratic equations. But if you're interested in where the quadratic formula came from, we could definitely talk about how to use the completing the square method. But in this video, I want to just focus on the quadratic formula. It's basically the formula is your answer. This is your answer, the negative b plus or minus the square root of b squared minus 4ac all over 2a. That is your answer. You just have to replace the a, b, and c with the numbers from your specific problem. So I'll write it over here. X is equal to negative b. So we're going to have a fraction. Negative b, so that's negative 4. B is 4, so negative b would be negative 4. Then we've got a plus minus. And we've got a square root. And we've got b squared, so 4 squared minus 4 times a times c. So we make this square root a little longer. We've got 4. The first number is always 4. Always 4. 4 times a, which is 1, times c, which is negative 10. I'm going to make my fraction even longer there. All divided by 2 times a, so that's 2 times 1. And now we just got to simplify, simplify, simplify until we can't simplify anymore. Shouldn't take too many steps here. So x equals negative 4 plus or minus. Now let's see what we got under the square root. 4 squared is 16. And then we got minus. 4 times 1 is 4, times 10 is 40, but it's negative 10, so that's negative 40. So it's actually minus a minus 40, which is plus 40. All divided by 2 times 1, which is 2. So now we can do 16 plus 40, right, under the square root. That is 56. So we got x is equal to negative 4 plus or minus the square root of 56, all divided by 2. All right, we're not done yet. We got to deal with the square root of 56. Let me switch colors here and go over to the right. Square root of 56. What is that? Well, 56. Let's see. Does that contain a perfect square? I think that is 4 times something, right? 4 times something. 4 times 14 should be 56. So the number 56 contains a perfect square, right? It's 4 times something. So we could write that as the square root of 4 times the square root of 14. And the square root of 4 is 2. So the square root of 56 is equal to, let me write the square root of 56 here, square root of 56 here. So the square root of 56 is 2 times the square root of 14. So let's continue on our problem here. Oop, one slide too far. So that's minus 4 plus or minus, instead of the square root of 56, we've got 2 times the square root of 14. All divided by 2. Sorry about that. We're almost there. So now it looks like we could cancel off that 2 on the bottom because both terms on top are divisible by 2. So we can factor the top. Greatest common factor. Right, going back a couple of sections, section 5 on factoring, pulling out a greatest common factor. So we can factor out a 2 a common 2 from each term in the numerator. So that'll be negative 2 plus or minus the square root of 14. Now the reason we want to do that is now we have a 2 on the top and a 2 on the bottom, and once we have factors, once we have factored form, then we're able to cancel. Okay, so those 2's, top and bottom, they cancel. Now I'm going to erase what I have here in black. We're done with that. Right? We're done with the square root of 56. I'm only erasing it because I need the room. I need a little bit more room. We're done. Now it's just final answer. Now that the twos have canceled, our answer is, let me put an x equals here. So let's say our final answer is x is equal to -2 plus or minus the square root of 14. -2 plus or minus the square root of 14. We have two answers because the formula, the quadratic formula, which is this. This is the quadratic formula. The quadratic formula contains a plus minus. So that means you have one answer with the plus, -2 plus the square root of 14, and one answer with the minus, -2 minus the square root of 14. Okay, now I want to talk about the last problem, problem 8. This will be a quick one because we're not actually solving anything. If you look at the quadratic formula, I wrote most of it in blue, and then part of it I used purple. Now the part in purple, let me highlight it. This part right here, the part under the square root. In this problem, it equaled 14. So we had two answers, plus the square root of 14 and minus the square root of 14. What if that gave us a negative number? Well, you can't have a negative. You can't have a negative under the square root. It's breaking a rule. We would have to also allow complex numbers if we had negatives under square roots, which we're not doing. So for the real number system, you cannot have a negative under a square root. So what I just highlighted in yellow, if you get a negative number there, then there's no solution. Anytime you break a rule, can't go any further. Right? So if part of your process takes you to a point where you're dividing by 0, you say no solution. If part of your solving process takes you to a point where you're taking the square root of a negative number, you say there's no solution. So there's not always two answers. Sometimes there's none. And occasionally there's only one answer. Because that, again, go back to that yellow highlighted portion of the quadratic formula. If that is a 0, if b squared minus 4ac gives you 0, then you get negative b plus or minus square root of 0. So plus 0 and minus 0, same thing. So number 8, this is the last one. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. I'm going to highlight, nope, not that one. I'm going to highlight the part under the square root. There's a special name for this, right? This in red, this is the quadratic formula. But inside of the quadratic formula, part of the quadratic formula, let me use, I'll use green here. This is called the discriminant. let's say the discriminant. So the discriminant is b squared minus 4ac. Okay? And that is the part of the quadratic formula that tells us how many answers we're going to get. So if the discriminant, so b squared minus 4ac is positive, well, we know what happens. Like in the last problem, the problem we just did, we got a 14 for the discriminant, positive 14. So b squared minus 4ac was 14. We got two answers. If the b squared minus 4ac, if the discriminant is 0, like 7 plus 0 and 7 minus 0 are not two different numbers. They're both 7, right? So adding 0 and subtracting 0 is the same thing. They both equal 7. So if you get a 0 under the square root, the square root of 0 is 0, and plus 0 minus 0 is the same, right? There's only one solution, because the plus and the minus are the same number. And if b squared minus 4ac is a negative number, if that's a negative number, well, you're not allowed to have a negative number under the square root. So as soon as you break a rule like that, you say there is no solution to this problem. So no solution. Okay, my apologies. Some PowerPoint just crashed. So we're back, and let's just in just about 30 or 60 seconds, let's just finish up this problem. I've said everything I need to say about it other than the final answer. So just real quick, the discriminant, let's put that down. The discriminant, again, is the b squared minus 4ac. It's that portion of the quadratic formula. So for this particular problem, the a is 5. We have ax squared plus bx plus c. We have an a, a b, and a c. The a is 5. The b is the negative 7. And the c would be the 2. And now we take these three numbers and we plug them in to the discriminant. So b squared is negative 7. Let's go back to blue. So that's negative 7. That's the b. We square that. Minus 4 times a, which is 5, times c, which is 2. So we get, that would equal negative 7 times negative 7 is 49, minus 4 times 5 is 20. 20 times 2 is 40, so minus 40. 49 minus 40 equals 9. 9 is a positive number, so there are two solutions, right? We calculate the discriminant, we get a positive number. If it's positive, we say there are two solutions. You could try solving this on your own. You might want to factor as a first step. Not in this problem, in general, trying to factor is a good first step. If you can't factor, and I don't think you could factor this one, so when you can't factor a quadratic expression, and you're trying to solve a quadratic equation by factoring, then a good plan B would be the quadratic formula. Okay, that's it for this video. Sorry about that technical snafu towards the end there, but I hope this was helpful.